ever drove down the road by a road construction project and wondered, what the heck are they doing? Well, my name's Alex Weiss, and as a senior in the Construction Engineering Technology program here at University of Toledo, I hope to answer some of these questions for you. Now, let's think about anything you want to do as a project. Whether you're writing a paper in school or building a shed with your dad on the weekend, you got to plan the project. So that's our first step. Planning is the most important part of any construction project. During the planning phase, we've got to ask ourselves questions such as, who's going to be using the road? What's it going to be used for? How many people are going to be using it? What are common traffic patterns? And what are the economic, how can we most economically and feasibly build this road? A lot of roads are built either for the public or for private use, so people want to get their money's worth. The public wants to get their money's worth, and the owner doesn't want it to pay that much. Let's continue on some planning ideas. Now we got to think of the constraints. Some constraints are things such as, what are the obstructions in the way? What I mean by obstructions is, when we're doing a road project, what's in our way here? You got to think, we have all these roads coming, or all these cars coming down the road. We might have weather. When we're building a new road, we got to think along the lines of, if we're building a new road on a new path, we got to think along the lines of, what's going to be in my way? So if I'm building a road through some wooded area, I got to think, there's probably some pretty big trees in the way. There's probably some environment there that I can't destroy because of environmental reasons. So these are all things we got to keep in mind. And then another thing is we have regulations and code. Just like a building code, roads have their own code that need to be adhered to too. It's different from state to state, just like building codes. Let's get ready to do some design work next. Alright, it's time to crunch some numbers. And in engineering, this is just a nerd way to say design. So when we're designing a project, we first have to go out and survey it. And so whenever you see someone on the side of the road with one of the tripods and this little device on top that they're looking into, they're surveying the road. And what they're doing is they're taking measurements of the road, widthwise and lengthwise, and they're also trying to figure out the elevations of the road. And this will come into play later. We'll discuss a little bit more. Another thing we got to think of are the location, soil properties, drainage, traffic volume, possible future expansion, and the environment. And these are some important aspects, so we'll go into them in a little more detail. Alright, location, 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 right? So if we're building a road, let's say in Florida, and then we're building another road in Ohio, they're going to be two completely different designs. Because in Ohio, we have to worry about freeze and thaw cycles. So after that first spring drive and you're hitting all those potholes, that's because the road is freezing and thawing. We get water underneath the road, and it freezes, expands, and creates a pothole. So when we're designing roads here in the colder climates, we got to design for that. And the way we do that is by getting more strict with drainage, which we'll talk about a little bit later. Next thing we got to think of is, let's say we're over on the West Coast where there's earthquake zones. We got to design a road that's going to be able to flex and twist a little bit more with the earthquakes. Now let's talk about some soil conditions. Now the soil is arguably one of the most important parts of a road. It gives it the building blocks. It's its foundation, what holds the road up. So when we get very poor soil, or excuse me, let me go back. The soil, how good the soil is will determine how thick our road needs to be. And the thicker the road, the more expensive it is. So the better the soil we have, the less thick the road needs to be, which means it's going to be cheaper. Now if we get really bad soil, then we start running into some problems and a lot of expenses. When soil is really bad, sometimes we can mechanically make it stronger by putting things such as wire mesh in it. We can even mix concrete in it. When soil is very bad and to the point to where it's just completely useless, we got to tear it up, sometimes up to 3 to 4 feet down, and completely replace it. And that process right there is very expensive. Let's continue with some design ideas. Drainage. As I said before, drainage is very important. Proper drainage will reduce the freeze and thaw cycle process. So if we can get that water up from underneath the road, it won't have the chance to freeze underneath there and expand and break the road apart. The other thing, you got to think, you got this pavement on top of dirt. The pavement is impervious, meaning water won't go through it. But if we do have water get underneath the pavement and the soil and it's not drained properly, it's going to wash the soil out and just eventually just erode all the soil from underneath it, taking away our pavement support, and it just cracks and breaks. Traffic volume. Traffic volume is a very important thing because traffic volume goes into all the design and equations when we're designing the road. Now, I can't get into that because we don't have enough time, but traffic volume is a very important factor, and we gotta be very cautious on how we get those numbers, and that's usually done just by studies and historical data. The next thing we're going to talk about is possible future development. Now, this isn't quite as important on public roadways. It's more important on the private roadways, where, let's say we're building a road for a factory, and they're planning on expanding in 10 years. And this expansion will cause more traffic. As I said, traffic volume controls design of the thickness of the road. So if this plant is expanding in 10 years and they know it, we're just going to design the road for the expected traffic in 10 years, instead of setting ourselves up for failure. All right, let's move on. Now we're ready for the fun part. We're going to move some dirt. And this is the part where we get ready to move the soil around and we get ready to install things in the project. And the first thing we're going to do is first thing we're going to do is create a path. Sorry about that. First thing we're going to do is create a path, and then the next thing we're going to do is install the drainage systems. And then after that, we're going to grade the ground and compact the soil. Let's go into these in a little bit more detail here. Now, when I say create a path, I mean we got to create the ground that we're going to be building our road. So a lot of projects we see are just a highway being rebuilt, and that's easy because you're just tearing off what's there and replacing it with new stuff. Now let's think if we're building a road through a new forest system, kind of like the example I used earlier, you got to create that path, so you're going to be tearing down woods, you got to think of the environmental factors. So when we're creating a project on an existing roadway, it's generally a lot cheaper and a lot easier and faster. A new roadway, especially through woods or mountains, we're getting into something that's going to be a little more costly. Now we're going to install the drainage. Like I said, this is very important. Two forms of systems we use when we do drainage is pipes and channels. Now, pipes are self-explanatory. They're just built underneath the road and then the water drains into them. Channels is something that a lot of people don't understand. When you're driving down the road and you see that ditch on the side of the road and you think to yourself, what the heck did they put a ditch there for? I'm going to crash into that thing. Well, it's actually there for a reason. That's where the water will drain into. And they use ditches because it's a lot more economical. If we designed and had to have a pipe in there that's as big as that ditch, that road would get a lot more expensive. All right, let's continue. All right, now we're to the very important part, grading and soil compacting. Now, I think I used the word grading earlier, and grading is simply just leveling the landscape to how you want it. If you want to do a contour, you want the road to slope, that's all grading. Compacting is when we actually compact the soil together. Now, the compaction process consists of laying layers of soil down, running a steamroller over it, like what we've seen on the side of the road, and then compacting it to these certain specifications that are set forth by an engineer. Now, some people wonder, why the heck do roads take so long? Well, this compaction process is what takes the longest, because we can only compact 3-inch layers at a time, and a lot of roads are up to a foot thick. So we do a 3-inch layer, compact specifications, we got to wait for the engineer to come out and check our design, and then we do it again and again and again until we get to the specified thickness. And that part is what really takes the longest time when it comes to building a road. Now, at this point, we're finally ready to do the fun stuff. We're ready to pave our road. Now, two types of pavement material are common. We have asphalt and concrete. We've all probably heard of both of them. Asphalt is a petroleum-based product, kind of like a tar, that has rock mixed in with it. Concrete is made of Portland cement, water, and aggregate. Aggregate just being a fancy word for stones. Since this presentation is limited to 10 minutes, we're just going to talk about the asphalt, because that's what we see the most common, especially on the highways. Alright, so asphalt, when we put it down, has to be really hot. It has to be up to 300 degrees, because we have to bend it and twist it into place. Think of plastic. When plastic is cold, it's not very flexible, but you melt it, and all of a sudden you can put it anywhere you want. Well, asphalt's the same way. Now, when we do this, we've got to spread the asphalt, we have to compact the asphalt. And Here I have a picture showing the process, so turn the lights off so hopefully you can see a little better. Not sure if that helped that much, hopefully it did. Here we have an asphalt spreader. It's not a very fancy name for it, it does exactly that. It spreads the asphalt in those thin layers, because asphalt, forgot to mention, is just kind of like soil. We got to put it down in thinner layers on top of one another and compact it and compact it. So this guy is laying the asphalt down in 12-foot wide strips, and then you have a steamroller coming behind it, which is about 6 foot wide. And he goes back and forth until the asphalt is compacted into place. And now we're finally ready to go for a ride. Here's our road. We got it nice and compacted. Soil, it's base. Remember, the soil is the most important part of the road. It's down there doing its job, holding the pavement up so we can drive on it and enjoy a nice leisurely cruise. I know in 10 minutes there's a lot of principles that I couldn't get into because 10 minutes isn't nearly long enough to describe how roads are built to enough detail. But at the end of the day, I hope you can take one thing away from this presentation, and that's the next time that you're driving through a construction zone, you don't think to yourself, holy crap, more construction. You think, hey, that's how they do it. Thank you for listening to my presentation.